All right, welcome back, everyone. Today we're going to talk about symbols and sets of numbers. So in this section, you're going to learn the definition of natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. You're going to learn the uses of equality and inequality symbols, how to use a number line, how to translate sentences into mathematical statements, and how to find the absolute value of a number. So natural numbers are essentially what we know of as counting numbers. 1, 2, 3, 4, 5, 6, 7, so on, forever. Natural numbers start at 1. Whole numbers are the same as the natural numbers, except the whole numbers include 0. So if we're using whole numbers, we start from 0. Notice that all of the natural numbers are contained within the set of whole numbers. These things will build upon each other as we go along. After the natural numbers and the whole numbers comes the integers. Integers include negative whole numbers and 0. So now we have all the positive whole numbers. So these are the natural numbers. All the whole numbers. And now we have all the integers. So these sets are just building upon each other. Integers just include negative numbers as well. Beyond the integers, we have rational numbers. Rational numbers are essentially fractions. Numbers that can be written as a fraction of two integers. So 2 and 5 are integers, and 2 over 5 is a rational number. It's a fraction of two integers. Negative 3 over 1, 8 over 7, 2 over negative 5. Those are all rational numbers. They're all fractions of two integers, fractions of two positive and negative whole numbers. Beyond the rational numbers are what's known as irrational numbers. These are very, very different from all of the other ones. Irrational numbers are numbers that cannot be written as a fraction or terminating decimal or repeating decimal. So for example, 1/3, which we just talked about, if we were to write 1/3 as a decimal, that's 0.333, and it goes on forever. That is not an irrational number. It's a rational number. It's a fraction of two integers, 1 over 3. Irrational numbers are numbers that are non-repeating, non-terminating decimals. So something like pi. Pi goes on forever. This number e goes on forever. The square root of 2 goes on forever. These are all irrational numbers. Cannot be written as a fraction. And finally, we have real numbers. Real numbers include everything we've already talked about. And we combine them all together into this one set we call real numbers. All of the real numbers make up what's known as a number line. We're going to be using a number line often in this class. So first, let's just determine what sets of numbers these following numbers belong to. So we have 5. And automatically, all of these are real numbers. Now, we can write 5 as a fraction of two integers, 5 over 1. Right? So since we can write it as a fraction, it's not irrational. And since we can write it as a fraction, it's a rational number. But it's also a whole number, a natural number, and an integer. Now, negative 3.6 is a little different. It's still a real number. These are all real numbers. It's not a whole number or a natural number or an integer because it's a decimal. But because it's a terminating decimal, it repeats or it ends, then it's a rational number. We could rewrite this as a fraction of two integers, negative 36 over 10. And so it's rational. So a number line is just a representation of all the real numbers spread out. And each one of these little spaces, or each one of the little dashes, represents an integer. And all the space between represents all the numbers between those two integers. Numbers on the left of the number line are less than those the numbers on the right. So 1 is less than 4. And so numbers get bigger going this way, and they get smaller going this way. Now this number line extends out to both positive infinity and negative infinity. It goes on forever in both directions. So even though it stops, these little arrows imply that it keeps going. And so it's going to go all the way out to positive infinity and negative infinity. So all of the real numbers are covered on the number line. So let's talk a little bit about equality and inequality symbols. So these symbols listed below are just used to describe relationships between numbers. If we have this symbol here, that just means A is equal to B. That means they're the same number. If we have the equal sign with a line through it, that means A is not equal to B. This symbol here is a less than symbol, so it says that A is less than B, so A is a smaller number. It can be found to the left on the number line. Here it says that A is greater than B, which means A is a bigger number than B. It'll be found to the right on the number line. And then these last two are just saying less than or equal to. So A is either less than B or it's equal to B. And then the next one, A is greater than or equal to B. This means that A is either equal to B or greater than B. So we want to determine whether these statements are true or false, and we can use a number line to do this. But I'm not sure that we necessarily need it. If we draw a number line, 0, 1, 2, 3, we can see that 2 is to the left of 3, so that means that 2 is less than 3. So this one is true. Well, we're going to draw a similar number line here. Here's 27, here's 72. 27 is obviously less than 72. But here it's listed as 72 is less than 27, so this one is false. For this last one, we have 0 is less than or equal to 23. And since we know that 0 is less than or equal to 23, we can say that that one's true. So now we're going to be able to translate some sentences into mathematical statements. We're going to use these equality and inequality symbols to write these given sentences. So for example, 9 is less than or equal to 11. So 9 is just 9. Less than or equal to, that's the symbol that we learned. And then 11. And that's all you would have to do to translate those things. So let's try some more. 8 is greater than 1. So we know 8 is just 8. And 1. Greater than, 8 is greater than 1. 14 is greater than or equal to 14. Greater than or equal to, just looks like that. Finally, we want to be able to find the absolute value of a number. The absolute value of a number is basically just the distance of that number from 0 on the number line, the absolute distance. In general, though, when you're finding the absolute value, you can just make any number positive. Okay, we write the absolute value with these two horizontal bars here, vertical bars. So that would be the absolute value of -3. Well, if you look at a number line, -3 is 3 spaces from 0. And so the absolute value, the absolute difference from 0 is just 3. But in all honesty, all you're doing is really finding, if you're finding the absolute value, all you're doing is just making whatever number is inside the absolute value positive. So we want to find the absolute value of 4. Well, the absolute value of 4 is just 4. The absolute value of negative 5 is just 5. Just takes whatever number it is and makes it positive. And then the absolute value of negative 2 over 9 is positive 2 over 9. So at the end of this lesson, you should be able to identify the different sets of numbers that make up the real numbers. So natural numbers, whole numbers, integers, rational and irrational numbers. You should be able to use a number line. You should be able to translate sentences into mathematical statements, and then find the absolute value of a number.